our today e-workshop series, Agriculture, IoT and also Big Data. Okay, this program is a collaboration program between the Faculty Agro-Based Industry, University Malaysia Kelantan with the World Resource webinar, where we have invited a distinguished speaker and expert around the world, okay, for delivering and nowadays and recent trend in the agriculture technologies. And today our e-workshop series will be about a experimental from IoT that will be delivered by our expert, okay, distinguished speakers, Prof. Balaji Ganesh, okay. So I will say explain about a bit on the IoT. I think you guys have heard about the word, okay, IoT, which is the Internet of Things, where IoT become a new trend, new disruptive in the agriculture productions, where the IoT focusing on the smart and also precision farmings, where we relying on the latest trend, cutting edge technologies to enhance our agriculture productions. So therefore, I will not explain further where this topic will be delivered by our expert, Prof. Balaji Ganesh, where the Prof will explain much detail throughout the session from 2 until 3 p.m. Hopefully, all the participants can wait and listen from our experts sharing session. So before that, I will start by explaining on the background of our expert today. Prof. Balaji Ganesh is complete his doctorate degree in the area of sensors from National Institute of Technology, Trikapali in the year 2007. Right now, Prof. Balaji Ganesh served as a Dean Research Professor in the Department of Computer Science and also Engineering. Part of that, Prof. Balaji Ganesh is a president for Institution Innovation Council, okay, established as per direction from the MHRD. Part of that, he also established 2 research laboratories, okay, namely electronic system design and optoelectronic sensor. Part of that, he has 6 PhD degree awarded, okay. And then part of that, Prof. Balaji Ganesh, okay, qualified patent agent, okay, where he involved a lot of drafting, research, litigation, and filing of patent applications, okay. And he also director and founder for IP Ever LLP, okay. And he have support more than 100 faculties, students, and also startup companies to file their patent, which is interesting to listen from our expert. And he has received a lot of funded projects, and he has published more than 100 national and also international and also conference proceeding within his field in the sensors and also smart farming, also smart agriculture technologies. So therefore, our invited speaker, our distinguished speaker, will be a great speakers for today session, and hopefully we can hear much a lot of knowledge from our speakers, Prof. Balaji Ganesh, and therefore I will invite him to deliver his speech and he's sharing knowledge with us for today's session. Therefore, Prof. Balaji Ganesh, are you there?
Yeah, good afternoon. Good afternoon, everyone.
Okay,
can I share my screen, sir?
Sure, Prof. You can share your screen.
Yeah. So, hope you are seeing my slide, right? So
yes, we can see your slide. Okay,
yeah.
Prof, we can start right now. Okay, your sharing session.
Yeah. Good afternoon once again. I join with Professor in welcoming you all for this webinar. And before anything, also my grateful. I am so grateful for the organizers for giving me this platform and an opportunity for sharing some of the research experiments that we conducted in our laboratory pertinent to Internet of Things. In our laboratory, we grouped Internet of Things based application in a 3 different segments. One is a medical electronics. It's a kind of how we could capture the biophysiological parameters through the different the sensor that we placed in the body sensor network. And we were so successful in capturing the patients, the users, their activity, as well as their the physiological parameters. Even very recently that we were by God's grace and fortunately we have implemented a system, and we were deployed in one of the leading hospital in India. Also, we are trying to commercialize our product, especially on the medical electronic side. Also, the IoT related thing, environmental monitoring. We have our own the wireless sensor boards. It is not the development board. We are not using at no part of time any Raspberry Pi or Arduino, that kind of the development board that we are not using. We are implementing our own board, and we successfully deployed in the pipeline gaseous substances leakage monitoring, and also the warehouse, the food grains quality monitoring, and it's a kind of the greenhouse monitoring also that we have done. Also that now we are looking at how effectively the drone technology, it could be useful for the smart agriculture kind of the thing, that also that we are trying now. So in today's webinar, as per the instruction from the organizer, we are so particular about explaining more towards than agriculture. For that, I am taking this as an opportunity to share 3 of our case studies. Since everything that we created from our practical, it's a kind of an implementation. Any point of time, if you have any doubts or any clarification, or if I do miss any point, or if I have made any mistake, you are most welcome to interrupt me, so that mutually that we could learn each other on this particular the technological aspect. So before looking at the case studies, of course, I would take some, it's a kind of the breathing time to explain about some fundamental aspects associated with the Internet of Things, and how the mechanism it is being worked on the Internet of Things, and how a beginner, how and where he could start it from, and what kind of the resources they may require. Because some students, they might be having an opportunity to explore the Internet of Things on their own. Some people, they wanted to begin somewhere, right? So for those students, of course, they also can consider about which particular the development board or which particular the module they may require to start to somewhere as their beginning of their Internet of Things. And the other important thing is, any point of time, of course, we are all here. Of course, our students are here. We have good the laboratory facility here, as well as our own research scholar setup. Along with them, we have the PG student and undergraduate student. They are all working on the same the research domain, Internet of Things and the wireless embedded system. So the students and of course the university and the professor, you are all most welcome to join with us in the collaborative work. Any point of time, of course, we could collaborate and we could make our work. Some of part of the work that we would try to implement here, and some part of the work in your premises. So that we could see the possibility of making it as a joint work in the near future. Also, that we are going to talk about some IoT in agriculture. What way it would be so specific to then agriculture? How then IoT, how it would be it really fits very perfect manner. What way the time as well as the cost factor involved in the traditional agriculture, how it would be it's a kind of the improvisation or the enhancement, how we could do with this particular the technological solution, Internet of Things, right? You would have had the discussion about it's a kind of the big data, but for all other kind of the thing, sensing, capturing the details from the environment, it is so important. So in that particular the case, of course, having understanding about the IoT, of course, it would give you the maximum opportunity to bring out some better from your own environment, right? So one such an environment, so today that we have taken it as an agriculture, right? So I told you the 3 case studies that I have brought here. Since I have been given 1 hour, so I could not able to explain the other projects work that we have done in our laboratory. But anyway, I would hope I would provide justice to the time that you are spending with us. So we are going to talk about IoT in food grain quality monitoring. We are also going to look at how in the horticulture, how in the greenhouse environment, what kind of the way that we could deploy then IoT enabled nodes and how we could capture the details, right? What for, and it would helpful to the farmer in to bring out the better yield. So that kind of the thing that we are going to look at in our the second case study. The third one is I was telling you about very recently, we in our laboratory, we wanted to deploy the drone, the autonomous drone, that to an autonomous drone, so that the farmer need not to be there. No, the pilot need not to be there. The moment the farmer, they are deciding the kind of the fertilizer, the kind of the pesticide they wanted to the spray, and the even everything it would be programmed, the navigation path and everything it would be programmed, so that these drone autonomously, of course, it would fly around the farming field and it would provide the kind of the required and an operation and everything. So very recently, of course, we have made such a drone, and even now what we are doing, we are giving these drone to the nearby the farmers, and we got their testimonial and everything. Of course, that too, that we are looking at some commercial avenues for the drone, the technology that we are working now. Internet of Things. The name itself, it implies that scattered objects, right? An environment, it is going to be interconnection of scattered objects in a backbone architecture. I strongly believe that you would have had the better understanding, but anyway, do patient with me when I am explaining you some other than example about the Internet of Things. For an example, you set the alarm clock. On the daily basis, you set your alarm clock by 5 o'clock. And the bus, normal, the boarding bus, of course, it would reach by 7 o'clock, and you have to reach the bus stop by 7 o'clock. So that is why by calculating that particular the thing, then you have to wake up by 5 o'clock. And you set your alarm clock by 5 o'clock, and every day it is the routine basis. The way how you were the normal life, it could be improvised when an Internet of Things based on an alarm clock. Imagine that you got, and you set an alarm by 5 o'clock in that Internet of Things enabled alarm clock. Imagine in your the home there is a water heater. That water heater also Internet of Things enabled one. And there is in the refrigerator. That refrigerator also Internet of Things enabled a refrigerator. That also that there in your the home. And the bus stop where that you would board the bus on daily. That bus stop also it has Internet of Things enabled one. And the bus, that also, of course, it is a GPS enabled one, and it has the Internet of Things, the chip. It has been incorporated within. These objects, that the bus stop, and your alarm clock, and your the water heater, all are scattered in nature. That all are not in the same place, very obviously. Imagine on the particular the day, the bus arrival time, it is not actual, it is not supposed to be the scheduled 7 o'clock, but on that day, it is going to be delayed by half an hour, 7:30. Whenever that kind of very dynamic data, of course, the changes in the data, it is happening dynamically. The bus, what it would do means it would give that particular the information to the bus stop, as well as all other interconnected devices. Now, your alarm clock, it got that information from the scattered objects from your bus stop or your bus, then it is going to be delayed by 30 minutes. What your alarm clock it has to do, instead of it makes an alarm by 5 o'clock as per your schedule, since the bus arrival, it is going to be delayed by half an hour. And imagine there is no all other the reason. So only because of the to reach the bus stop by 7 o'clock that you made the alarm clock by 5 o'clock, not by any other reason. You just imagine in that way. So your alarm clock, instead of wake you by 5 o'clock, instead of it raises an alarm by 5 o'clock, since it understands there is a delay of the bus arrival by 30 minutes, then its alarm clock, of course, autonomously, it would be set for 5:30 instead of 5 o'clock. When the normal time, the heater, it has to be switched on by 6 o'clock. Now what would happen? There is going to be a 30 minutes delay. Then instead of the water heater, it switches on by 6 o'clock. Now it is going to happen on its own 6:30 a.m. But you are still, you are in your sleep. You do not know what is happening between these scattered objects, the bus stop, and the water heater and the alarm clock. Everything, it gets an information, and on the basis of the program, on the basis of the configuration that you set, then very obviously everything it provides some kind of the good services to you without our knowledge. That is going to be the wonderful thing. Of course, even in today's world, of course, we are all enjoying that possible, of course, because of the Internet of Things, the platform. Of course, it has been implemented. Even you and me also can do that kind of the thing within our home. It does not mean that I may require any kind of the other the devices which I need to procure from the market from other manufacturer. If I have a simple the development board, I can integrate all my scattered objects in my home environment. Even we have done it in our home. We never, I told you, we never depended on any other the development boards are there in the market. Instead, that we are developing our own development board. Only thing is what you have to do, that particular the microcontroller that you are choosing, of course, it has to be Wi-Fi enabled, right? So if that is the case, then very obviously, or at least to some extent, the Bluetooth enabled. So if that is the case, of course, you can make the control over the particular the chip, when that chip, of course, it has been integrated with any physical objects. That is what that we have to plan it. It is on the basis of the creativity. It is on the basis of how I wanted to interact with my physical environment. Then that is going to be my the limitation. If I want to interact with my environment to that multiple fold, of course, I can integrate my sensor in all the places. Even what we have done in our home, we really do not know the kind of the service condition of the AC machine, air conditioning machine. What we have made it available in our air conditioning machine, we have incorporated a chip. It is not the original manufacturer, but we have done on our own. But that chip, of course, it would rate the power consumption of the AC. For an example, if that particular the AC is actually it has to consume 2000 watts, but particular that day it is consuming more power. It means that something it is happening within the AC and it requires some kind of the repairing activity. What our AC we would do means we have made a mobile app. So for that mobile app, we would get the information from our AC. And that particular the app that we have given to our service professional too. So the service engineer also that he would get the kind of the information directly from our AC. That is possible. Even instead of that you are calling him the service professional, service engineer, he would call you, sir, your AC consumes more power yesterday night. I wanted to check it out. So that kind of an opportunity, of course, you would get when you are making your devices to talk on its own, to think on its own, to configure on its own. That would be possible through this Internet of Things architecture. So that is why that I was mentioning you here. All are connected and sharing, talking. Of course, it would express its own data, what kind of the input it gets and how it would process, how it has to compute, and what the way it has to deliver to the user. Even though the user all the time he is looking at all the time he is expecting the data or not. In the earlier example that I was telling you, that still you were in your sleep, but behind the without your intervention or without your knowledge, something it is happening in your own environment, right? The kind of the way that you programmed within your the devices, that would be possible. That would be possible. So today's, of course, all the students, of course, you have had the number of the development boards in the market. Of course, all are very it's not that much of very costly enough. Of course, it all very very within your budget. Of course, in India, of course, our student, they were able to get 300 rupees, right? It is very, very minimum cost. Even when you are visiting your for an example, the McDonald's or something, so that particular the amount only that you have to contribute for procuring any kind of the devices now. So if you are if you could sacrifice, of course, that particular the thing, of course, you also can involve these kind of the researchers. Hope you would do that. So this particular the statistics, of course, I have taken from this report. Of course, you could understand how big the Internet of Things is. Even the people are telling that that today, of course, there is billions of devices, of course, we have been interconnected with, and that number, it is going to be multifold. The number, even each and every year, the number of the devices, of course, it has been added with the Internet of Things, the knowledge, and it's a kind of the sophistication, of course, it is increasing. So that is where the big data, that kind of the thing, it requires the more. Because now what is happening, earlier our the physical the object, it is not speaking with you, right? It was not speaking with you. Then obviously that particular the time there is no the requirement of the data analytics. Now what is happening? All the objects, all the physical object, it start to speak to you. For an example, you consider a chair. You consider a chair when it has been assembled with an appropriate and an IoT, then it would talk to you whether it has been occupied or not. Then what obviously it is required, then you have to manage this data, you have to capture the data, and you have to analyze, you have to provide some kind of the analysis part, and you have to store this data for the historic analysis, then all those kind of the thing. So that is going to be that much of big, right? So I leave it to your own imagination how it would be. So the application of IoT, I need not to mention the kind of an application that we would talk about in all the areas, right? From the smart cities, smart environment, smart energy, smart agriculture, e-health, retail market, logistics, industrial control. In all those places, of course, you would see the intervention or the penetration of Internet of Things. So my humble request to all the students, and please think about starting from somewhere, because in the future, there is going to be a number of interconnected devices. And that time, your younger brother or someone else, if they are asking you something, some basic on that. So hi sister, or hi brother, do you know how it is working? How my signals are being captured? How I could get the information from my tube light or the fan are there in my environment? How it is talking? how it is talking to me, what kind of the communication that I'm getting from the fan and the mobile phone, how it is possible. When the people are asking you to that kind of the very basic doubt, then very obviously that you need to tell them, this would be the background story, right? At least to some extent you need to understand what is really happening with. But I would tell you, it is a so interesting domain. It is a so interesting domain, right? So believe me, you please start from somewhere else, and the moment that you are able to make the physical object to talk with you, then you would get that kind of the interest, right? So I told you how you could start it from. You can consider any kind of the wireless communication interfaces. It could be a Bluetooth, it could be a LoRaWAN, or it could be a simple Zigbee module with a different the wavelength, and you can have this kind of the NB port, and any kind of the wireless protocol that you could think about. And you also can think about the Wi-Fi. Of course, you can have the number of the protocol interfaces, right? So through which that you can make that kind of the interface, right? So what we could do means, if I do get another opportunity, I would tell you how, from the basic point of view, if you are requiring the basic point of view, from day 1, day 2, and day 3, how you could construct a simple IoT enabled an application. Then I could tell you the kind of the programming involved, kind of the hardware configuration involved, and everything in other this kind of the webinar series. Also, that one of the important thing is the pros and cons of any particular the technology part. Of course, the advantageous side that you would look at, improved customer engagement with their own the physical environment. The technology optimization also, it would be there. The waste, it would be so reduced. That too, one application, the case study that we are going to talk about, how we could reduce the waste. Enhanced data collection, because each and every object that we are going to interface with, so very obviously it is going to be enhanced the data collection. Also, it has some kind of the issues with, but it is not that kind of an issue. But when we are talking about any technological advancement, there might be so kind of the demerits it could be attached with, right? But as an engineer or as a professional, then it is our duty how we could solve this issue. So that responsibility that we do have. For an example, the security. Because all the devices have been interconnected in the domain, so there might be the high chance of the data, it would be stored by some other unauthorized person. How I am going to secure the data? That is going to be a very the key aspect the people are worrying about, that it would affect my privacy. It would affect the people are really worrying about. So what would happen if my data, of course, it has been listened by someone else, unauthorized person. So unnecessarily that I'm giving the opportunity to the unauthorized person to listen about what is happening inside my home. So that kind of the thing, of course, when we are looking at in any technological aspect, it would be there. But for that alone, that we cannot tell that I cannot use the technological advancement. Of course, we can, but we need to understand the kind of the issues are there and how we could protect ourselves. That is going to be the wonderful thing that we have to take care of it. Once if we are so secure, then no one in the world, they could able to steal our data if we are so protected, right? So the privacy, the complexity involved. So I told you there should be some kind of the procedure involved, how I could do this kind of an operation. When I am not understanding the implementation scenario, how it has been built with, then very obviously there might be a complexity. But this complexity, of course, it would be eradicated with the proper understanding, clarity, as well as the confidence. Then very obviously there might be the kind of the complexity that we can remove from this the issue part. The flexibility, of course, because there are multiple the vendors, right? The multiple vendors, multiple manufacturers, even though the protocol standards are the same one, but very obviously the exchange of the data from, because in that example too, you just imagine the water heater, it is not going to be the same manufacturer who has manufactured the watch. The alarm clock, it is not being manufactured by the same manufacturer who has manufactured the bus stop. It would be the different vendor or different kind of the interface it require, right? The compatibility. But I could tell you, when we are implementing, of course, we can configure our system which would get the information or which would deliver the information to any kind of the devices within the scope, within the security scope, right? So, and the complaints also, because when we are looking at the ISO standard or the TCP/IP, everywhere that we were talking about some kind of the standardization, right? The if I have looked at the open system interconnection model, of course, it's a 7-layer model. And the TCP/IP, of course, it's a 5-layer. Everything, of course, it has been standardized, but still then now the IoT, it has not been standardized. But believe me, that won't give you that much trouble to start from somewhere else, right? So we need not to worry about that kind of the thing. So how I could become an IoT developer, you can understand that I have taken from this information from this web page. So all the 6 tips that I have taken from, we have to understand the sensor part, because we have to interface the sensor, and we have to understand how the sensor, it could be interfaced with my IoT enabled the microcontroller. To some extent try to learn the Python, because the Python is more versatile, the language package. Of course, most of the processor with the Wi-Fi enabled would support the Python, right? So, and the most importantly, the cloud interface and everything, that time also that you would get some kind of the good support from the Python on those particular the implementation too. So in our lab, of course, we instruct our student to start somewhere else with the Python, the language learning, right? So Arduino or the Raspberry Pi, it is going to be a good option, or you can buy some kind of the ESP module too. You may find the community. Of course, in your own the university, you would find the community who would help you, or otherwise in web sources, there are also the number of the community also there, and our student group also there. If you can, you could join with us. And so we have to upgrade our knowledge on hourly basis. So that is also so important. So the right now the topic that we are going to talk about, how the IoT in smart farming, the climate condition. So to monitor the condition of the crops and the weather surrounding them. It's a kind of the precision farming also, that you can kind of the thing how you could deploy our sensor to have the effective and the intelligent and quick decision. So on its own, it is not the user, right? So please understand. And the smart greenhouse, to make entire process cost effective and increasing accuracy at the same time. Data analytics, by using predictive analytics, you can get an insight to make better decision related to harvesting. Agricultural drone, so for the assessment of the crop health, crop monitoring, planting, spraying, field analysis. Very obviously that you can venture into agricultural drones. So we are going to have the discussion on 3 case studies. This that we implemented in our laboratory, of course, our students. So the first one is augmented reality and Internet of Things supported warehouse monitoring system. Of course, I do believe in the Malaysia also, that is going to be the warehouse, right? There, the grains, the different grains, of course, are being stored. In India, so it is a Food Corporation of India. They are maintaining all the warehouse environment. There, the tons of the food grains are immediately after the harvesting, it is being stored, even for 1 year, 2 years, and sometime the 3 years. But unfortunately, what would happen means because of some mold or the rat or the other kind of the humid condition, the food grains are sometime, of course, the wastage, it was so higher. Of course, the last year statistics, of course, it was telling that more than 65,000 crores of food grains, the food grains are being spoiled because of the prevalent situation are there in the warehouse. This from the leading newspaper. Even there were some then argument, it happened in the parliament too. So kind of the warehouse, the advancement it requires to minimize the food grain, the wastage in the warehouse environment. For that only that we proposed this particular the thing to Department of Science and Technology in the year 2015, and we got funds from them and we implemented this project. Now in some other the food grains, the warehouse, of course, we successfully implemented this model, and we proved that this kind of the system would bring down the wastage of food grains. So it is a proven model that we have done, and we got the patent too for this particular the model, Indian patent I'm talking about. So the idea is to provide the earliest possible warning of undesirable biological activity in a grain storage bin, and this system can be customizable and reconfigurable as per the requirement. And also that we have adapted the augmented reality. The moment the user he wanted to look at where the food grains, the spoilage, of course it is happening, and the entire the navigation map, of course it would the system it would provide to them. So that kind of the thing that we have implemented. So you can see here the model, the warehouse environment there, that you can see the number of clusters of wireless sensor networks. All these nodes are Internet of Things enabled one. Even you can see here, this is the coordinator node, the central node, and you can see here the number of wireless sensor nodes, right? So the number that we have given as the 106, right? This is the one cluster of the sensor network. And in the food, in the warehouse, this kind of the number of the clusters that we deployed, and all the nodes directly it has the communication with the server. That server interface, of course, either you can do with your mobile phone. We implemented the mobile, the application programming interface, the mobile app, and we successfully launched it in the Google. It's the thing too, and you have the internet server here, so that whenever the central node collects the data from the all other the wireless sensor node, it conveys that information to this coordinator node, through which the server it gets the information. Similarly, I told you this is the Internet of Things environment. So all the node directly does not depend only with the internet server. Also, it delivers the information directly to the user. So the user, whenever he wants to look at any particular, for an example, he can click on this node. If he clicked on this node, of course, this node data, of course, it would be listed out. And if the user, when he is entering into the warehouse environment, the moment he wanted to go there, and the moment he clicked on the particular the node, of course, the entire the navigation map and everything, it would be displayed on his the mobile phone, so that in the entire the path, how he could reach the particular the destination without any camera, of course, it would list out, because all these sensor nodes have been interconnected with each other. So entire the location map, of course, the user he would get to his the desired place to reach, right? If you have any doubts on this, that I could explain you. So this is what that node that we implemented. I told you we never depended on any other the sensor nodes are there in the market. Development nodes are there in the market. We ourselves we implemented this. This one is the handheld kind of the thing. It is a kiosk that we are referring with. And you can see here, this is the chamber 1, chamber 2. This is the one cluster, another one cluster. Of course, we have deployed it in the cluster manner in our warehouse environment, and all other the node information directly it would be. So you can see here the coordinator node. and we have used the CC3200 from Texas Instruments as an coordinator node, which would deliver the information to the server node. And this node also, it would be having the CO2 sensor, humidity sensor, and the moisture sensor, the temperature sensor, and that also not only it would capture the details, also it captured the details from all other sensor nodes. You can see here one CO2 sensor, right? So it has the CO2 sensor, humidity sensor, and the temperature sensor, which would record these three parameters, and those parameters it would be collected directly with the cloud server, also through this coordinator node, right? So, and we implemented the cooperative communication here. So in this cooperative communication architecture, the data loss, of course, we minimized to the level of 0. So there is no data loss, of course, we never experienced because of this cooperative communication. We implemented two different then architecture. One is the cooperative communication mode, another one is a network coded cooperative communication mode, right? So both architectures, we understood that there is no data, the loss that we experienced in our the sensor network architecture. So you can see here, this is the user place, and whenever he wants to move at any other place, what he could do means he can just click on this particular node. Even we recently deployed it in one the shopping mall. There what we have done means we deployed these sensor nodes in different shops. The moment the user enter into the shopping mall, and it is going to be lakhs of the square feet, right? So very obviously he has to look at which particular the shop he wants to go, and he has to ask the manual operator, the manual person, and he has to ask the entire the direction. Instead, we deployed this kind of the mobile app to their user in their the mobile phone. The moment he wants to go to a particular shop, he has to click on the shop. This particular the sensor node, of course, it would provide him the entire the navigation map. That also one other application that we have deployed with an augmented reality kind of the thing. So you can see here, this is the literature it says about. If it is more than 4,000 the ppm range of CO2 means, of course, there might be a higher chance of the insect presence. When it is in the within this range of 1,500 to 4,000 ppm, of course, the severe mold infection, of course, it is there in the warehouse environment. This and all the information when our node it recorded any particular the CO2 level, of course, it would tell the concerned the warehouse operator, the manager, about the prevalent situation are there in his own the warehouse, so that he could do some kind of the mitigation activity. So you can see here when he yes sir,
sorry to disturb, you have like 5 to 10 minutes to compile.
Okay. Yeah,
sorry for that.
Okay. And we implemented this kind of then algorithm in order to save the energy consumption and everything. So all the time our node would not capture the details unless otherwise there is a necessity for that. So what we would do means you would have seen the kind of the sensing mode and the computation mode and the sleep mode, right? So all the time what we would do means we would keep our microcontroller in the sleep mode. Whenever the sensor gets the information, that time only it starts to wake up and it tries to capture the details. So that with this kind of an approach, very obviously you can minimize the power consumption of the node, right? So that's what that we have done. So this and all the results that we obtained in our experiment. So you can see here RSSI value with the different the transmission power range and the distance also that you can see, and signal to noise ratio and the packet delivery ratio that we obtained. And the node placed at the different height, 5 feet and the 8 feet, kind of the temperature and relative humidity and the CO2 level that we were captured with another height, because the carbon dioxide penetration level, it would be very different. And another one, the case study that we have done, the same approach, but for the greenhouse environment. So the greenhouse environment also, the parameters to be monitored, the capture are the temperature, humidity, and the CO2, right? So predominant parameters. And also what we have done, we interconnected our nodes with the all the solenoid valve, the oxygen cylinder, and it's a kind of the water sprayer. And in all those places, we have made it as a actuator kind of the thing. So the user need not to be there in the greenhouse environment, and everything it would be automated, and it would record the CO2 when there is a required amount of the O2. If it is not there, when very obviously it starts to open the solenoid valve for the oxygen cylinder. When the water spray, it has to be taken. Then by monitoring the soil, the moisture level, then the water spray, of course, it would be switched on its own. So, and when during the night time, the CO2 level, it would be more, and very obviously it would open the ventilator system and everything that we have done in a very automated manner. And we proved that to the farmer for the particular the crop, the yielding time, the yielding, it was so higher when it has been done in this kind of the very automated manner, right? So we have had one web page. Through the web page, the user can monitor the details, and you can see here the different, the kind of the environment, the kind of the result that we obtained. So you could see here the CO2 concentration before sunrise at 5:40 p.m. So it was so higher. Then very obviously this particular the time, so our the ventilator system and everything, it would be done so that you could see here a very steep the changes in the CO2. It is happening. So also that we were talking about this autonomous drone. What this autonomous drone would do means the user can make the navigation map, and the kind of the spray, the nozzle, and the kind of the thing it has to be done, and everything it would be done. Everything it would be done on its own, right? So this, of course, very recently that we implemented, and we have given this particular the drone to the users, the farmer, and they are making use of this, right? So in this kind of an example, or if you I am most welcome, and you are all most welcome. You could join with us for any collaborative work in this the technological field. Any question that you would ask me?
Thanks, Prof. Balaji Ganesh. Very packed and very interesting sharing from Prof on the experimental from IoT. Okay, we basically, also in the field of, precision farming or smart farmings. Maybe in future we can collaborate, Prof. Yes, maybe in the project, some sort of like, rice
Thank you.
farming, okay, anything related to the greenhouse in the UMK, okay. Perhaps some of the data analytic, can get supervision from you too, okay, for one of the students or postgraduate in the future. Prof. Balaji.
Yeah, thank you, sir. Thank you. You are
So,
most welcome.
so basically, I have a question where, in term of this, storage room, from your experience when from your experience when you do with any community, if you have done this experiment with the community instead of in situ or circle experiment, okay, have you encountered any like moisture problems or humidity problems within the grains? How you kind of nodes or sensor that you can use to navigate this data, and then you keep that data all the times. What kind of sensor or anything system that you use, or storage in terms of detecting the humidity? Okay, share, Prof.
Yeah, fair, sir. Actually, we have had an appropriate the sensors and everything, and we made our system not to be get influenced on the prevalent situation or the thing, and of course, so that would be the situation where you would expect some kind of very abnormal the humidity and the moisture level. So we have the appropriate sensor, and we were able to capture, because those things are so the important the parameters, right? So that only it would give you the kind of the conditions are there in your the environment. So of course we have done that, sir. And thank you for your consideration for the joint work.
Yeah,
So
because
you are most
because
welcome.
because we have a kind of a humidity, especially we have sometime in one day we have morning we have rain, and then in the afternoon we have hot temperature, and then in the evening we have rain one more time. So
Yeah, understand.
basically we have fluctuate in the humidities
Yeah. Yeah.
measurement. So if affect when we plant our for example like some of the crops we plant in the greenhouse, and then
Yes.
it attract more the disease. So if you have that consensus, maybe we can collaborate further within to implement in
Yes.
our greenhouse, and then monitor on it. And then part of that, I also would like to ask in terms of the drones, okay, because okay, my field also in the drones. Okay, how's the mapping terms when you say the autonomous? Okay, how far it can goes, and how high is your sensor, the Wi-Fi connections with your systems that when you implement the autonomous, especially when it goes to the rural area where the internet was not able to reach, and then how is it in your your experience? Are you able to do that in the India basically?
Yeah, in the first your the thing, the moisture, of course, I told you all these thing. Of course, it is not. We have not made it as an experimental purpose. Of course, we are looking at the commercialization potential too. So all these things are made as an end product. So any point of time, of course, we could collaborate, and even I could send you some of the notes what we have made here, and you also can test it in your own environment, and that kind of the possible collaboration also that we can do, instead of all the time that we are looking at the Raspberry Pi or something. You can think about using our sensor node that we developed, and that thing, even the humidity, the moisture sensor, and everything that we have incorporated, that you can do it with the drone, of course. Not only the GPS that we are looking at for the possible autonomous navigation purpose, also we have had our own the mapping. So in the different the places, of course, we have the node placement and everything. The drone, when it flies, when it flies on the farming land, of course, it gets the coordination point from the ground medium, so that in that particular the time that you no requirement of any existing the technology, even when there is no GPS, and when there is the kind of an issue it comes, you have your own the coordination map,
So
right?
basically, my experience when I flying drones in the rural area, especially in the forest area, I
Even
need
in
to
that place
yes,
too, sir, even in
I
that place too, this kind of the technology that we can adapt, even
because I
if
need
it
to
is
fly
yeah, please.
manually. Basically, it's very hard to fly autonomous because I use DJI drones, so Phantoms and also Mavic 3. So when I try to fly, to set is automatically when I set the waypoint within the system. But again,
Sir, yes, I understand. For your kind information, yesterday we made one drone. That particular drone, what it would do means, for an example, if you want to track a particular person,
mm,
right? What we would do means we would make our drone to understand which person it has to track.
oh, I
The
see, that's good.
drone, it would start to capture the person. Once if it captures the person, then it starts to follow it, it starts to track the person. It won't require any kind of the pilot.
That's very
Instead, it's the navigation map, and if it's the flying and everything, it would be on the basis of the person he is moving on the ground.
that's good. That's good. That's good. That's good to
Yeah,
hear that.
that also that we have done yesterday. So yesterday too, that we made the demo of this particular the thing. Even we wanted to adapt some kind of the gesture. The user, when he is being tracked, right? If he made any kind of the gesture or something, on the basis of the gesture he is making, the drone, it has to be controlled.
That's good. That's good because
Yeah, that
uh,
also that we have done in in our extra day experiment. Then in
because
that aspect also that we could collaborate, sir.
that's good. That's good because when I fly in the jungle, basically, I need to fly manually. When I try to put, autonomous or automatically when the location when we like to land and also,
Yes.
fly is okay, but when landing the GPS, it's not that accurate. It will go to the in the jungle. So
Yes. Yeah, yeah, I
so
understand. I
yes, I'm
understand.
afraid that that's
Yeah.
why I basically just fly manually and then not fully autonomous. Maybe
Yeah.
perhaps you'll have drones. Maybe we can bring here and then do some sort of collaborative and then some sort of this continental or regions, experiment, okay, within your technologies, within the Malaysia area.
Yeah.
Because
Thank you, sir.
you're not mistaken, in Malaysia, they have a lot of connection basically for these, GIS, basically GPS, because we have a
Okay.
lot of satellite moving around here.
Okay.
So it will be beneficial for your technology to be improved further. So
Yes, sir. Definitely that we can collaborate, sir. In
that's
that
good. That's
aspect.
good.
Yeah.
Let's see, we have any question from the, for the floor. No question. So, Dr. Omar, you have any question you'd like to ask to our speaker?
No, but the thing is, we are open to questions. You can send us through email also.
Correct. Because in my experience, I also use Raspberry Pi. Are you using the Raspberry Pi, Prof. Balaji?
We are not using the Raspberry Pi, sir. We are developing our own the microcontroller board.
Microcontroller. So you
Yes.
in terms of the interface, controlling all the data
Yes,
or
everything that
punching.
we are developing from the scratch. So we
That's
would
good, that's
buy
good.
only the microcontroller, the microprocessor, and we would be having our own PCB board and for our board, for our boards.
Because I have my own Raspberry Pi and everything on the systems, and I also have the sensors.
Okay.
All right, now I try to, if you have a sensor in terms of lux meter, you have the lux meter for the lighting in the indoor farmings. Maybe we can collaborate on that with the University Malaysia Kelantan, because I have a intention to further.
Dr. Noor, the thing is, we can use Arduino or Raspberry Pi,
Yes,
but it all depends on if it is a proven model, you have it. Otherwise, you need to go and create it.
Correct. Yes,
so
correct.
that's what Dr. Balaji is telling. He'll get the board and then he'll construct the elements of it.
Correct. That's good. That's good, because I'm using the Arduino and also Raspberry Pi. Only that now I try to connect with the lux sensors. If you have the lux sensor at your own, then they will be beneficial for our indoor farming experiment in the futures. So again, we don't have any question from our, for our audience and also from our Facebooks. Again, I would like to send thanks a lot to our distinguished speaker, Prof. Balaji Ganesh, okay, and then for our audience for today's session. And for a reminder, tomorrow we still have another session, okay, with Mr. Igor Jursic, okay, on this
tomorrow.
Yeah, tomorrow on the title of Smart Agriculture and also IT Business segment, and hopefully for the audience out there, you can join, okay, for tomorrow's session from 3 to 4 p.m. and hopefully from 3 to 3 p.m. okay, Malaysia times. Hopefully you guys can join and learn a lot from our expert, Mr. Igor Jursic. Okay, that's all for me. I think thanks again for our distinguished speaker, Prof. Balaji Ganesh, and hopefully we have collaboration in the futures.
Thank you so much for the given opportunity. And my kind request is, please, if you are collecting the feedback, please share it with me so that for my better learning, so understanding, right?
Sure.
Yeah, thank you.
We have further collaboration in future. Sure, I will contact you. Thanks a lot, and thanks a lot for Dr. Umar.
Thank you.
Yeah.
And thanks a lot for the audience.
Yeah, thank you, Dr. Krishnan. Bye.
Okay, bye.
Yeah, with all your permission, I am leaving. Thank you.
Okay, thanks a lot, Prof.
Bye.
Okay, bye.